Hey everybody, here are your answers to the review sheet for 1 to 4-5. If you know how to do these problems, feel free to skip through the video. You do not have to watch this whole video. It is provided only to help you with the problems that you're not sure how to do. So we'll get started. Number 1, we're going to change this to degrees. You've done this a zillion times. Pi is 180, divided by 4 is 45, times 5 is 225. That's all you have to do. That's the answer to the question. We're moving on. Now we're going to change this one into radians. So we'll set up our proportion. Pi over 180 equals x over 300. Now, pi over 180 always stays the same. Here, sometimes the x goes on top, sometimes on the bottom. This time, clearly on the bottom, because this is a degree measure, and it has to match up with that degree measure. So we'll cross multiply. 180x equals 300 pi. We'll divide by 180, so we get 300 pi over 180. We will reduce our fraction. These cancel. We have 30 over 18. That would be, let's see, 6 goes into both of those, so 5 pi over 3 is our final answer. The next one has a star next to it. That does mean calculator. So we are going to type into our calculator. Please make sure, first of all, that you are in degree mode. And then we're going to type in 189.732. We're just going to type that decimal actually in on the calculator. Then we are going to go to second angle. And remember, the angle button is the apps button. So second angle, and click down to item number 4, which is DMS, degrees, minutes, seconds. You'll need to press that button twice, and then it will say 189 degrees, 43 minutes, and 55.2 seconds. So if that went too fast for you, just go back and replay that again. You need to go into your angle menu, second apps, click down to DMS, degrees, minutes, seconds. That's what you were trying to get. So the calculator will give you the degrees, minutes, seconds. Now we're going backwards. We have the degrees, minutes, seconds. So we will type 28, and then we will go into our angle menu and choose the degree mark so that you're, oh, I'm sorry, it's 283. 283. Go into your angle menu, choose the degree mark, then type 10, go back into the angle menu, click down to the minute mark, and then type 13. Now the seconds. Remember, the seconds are in the alpha plus menu. So we'll have to hit alpha plus. That will pull my seconds up, and press enter. And that decimal is 283.1702778. No rounding instructions were given, so we'll just say all of that. But on the test, you'll be rounding off. Good. Now, the next one, we're back to no calculator. It says find the arc length. This is the arc length. Remember that arc length equals radius times radians. Kids, this could not be any easier. The radius is 6, and the radian measure of the angle is 1.7. So the answer is just 6 times 1.7. And 1.7 times 6 looks like it's 10.2. That's all there is to it. Please do not make that hard. Arc length is radius times radians. Next, what angle measure describes northwest? This would be northwest right here, right smack dab in the middle of north and west, which means since this is a 90-degree angle, these two are 45. Northwest splits the quadrant right in half. Navigational angles, remember, are measured from due north. They're different than other angles. We're measuring from due north. So we've got This is 0, that's where we start. Here is 90, here is 180, here is 270, and then we'd be back around to 360 if we went all the way around. That is different than other angle measures. Navigation is different, starts at 0 up top. So we need to go all the way around to northwest. So that would be 90, 180, 270, and an additional 45. So that angle measure is 315. 270 plus 45. Now we're asked to find all the trig functions given that the cosine is 3/4. Now if you don't know anything else, you better be able to fill this one in. If the cosine is 3/4, the secant would be 4/3. Now let's draw a picture of this situation. We have an angle in quadrant 4. Now, did you catch that? How did I know it was in quadrant 4? Well, part of my directions tell me that angle is between 270 and 360. This is not navigation. This is our regular angle measures. So this is 0, 90, 180, 270, 360. So I am in quadrant 4. And I know the cosine is 3/4. Cosine is adjacent over hypotenuse. Now I'm missing this side. I don't know what it is. So I'll do my Pythagorean Theorem. Do it right here. So I have 3 squared plus x squared equals 4 squared. 3 squared plus x squared equals 4 squared. So 9 plus x squared equals 16, x squared equals 7, and x equals the square root of 7. Actually, in this picture, it would have to be negative because we are going right and down in the 4th quadrant, negative root 7. So if I'm looking for the sine, I will do opposite over hypotenuse, negative root 7 over 4. The reciprocal of that would be negative 4 over root 7, which I will rationalize and get negative 4 root 7 over 7. The tangent is opposite over adjacent, negative root 7 over 3. So the cotangent would be 3 over negative root 7. Again, I have to rationalize, so I get negative 3 root 7 over 7 for my cotangent. Now we're going to do some problems that we have done a ton of. You've had quizzes over, so you're probably expert with these. We are going to not use our calculator. This is a no calculator problem. And we are going to find the cosine of 3 pi over 4 and the tangent of 5 pi over 6. And the sine of 270 and the secant of negative 5 pi over 4. So we have a lot of these to do. So here we go, step 1. We're going to change this guy into degrees. So we remember that pi is 180, divided by 4 is 45, times 3 is 135. So we have a 135 degree angle. Remember, we are not doing navigation, so 135 will be over here in quadrant 2. If this is 135, remember this is the angle you need. So how much farther do you have to go to get to 180 to finish this angle off? Well, it looks like we need to go 45 degrees. So the sides of that triangle, you know, are 1, 1, root 2. It's a 45, 45, 90 triangle. This side would be negative because in quadrant 2 we go left and up. Left is negative. We want the cosine. Cosine is adjacent over hypotenuse. That would be negative 1 over root 2 which I will rationalize, and my final answer then is negative root 2 over 2. Now I'm going to do exactly the same thing with this angle. First I have to figure out how many degrees it is. So pi is 180, divided by 6 is 30, times 5 is 150. So I'm finding the tangent of 150 degrees. And lo and behold, it's in the same quadrant, because this is 90 and this is 180, and 150 would be in between 90 and 180. However, the angle this time is not 45, the angle this time is 30, because to get from 150 to 180, I would need to go 30 more degrees. Now I have a 30, 60, 90. I know across from the 30 is 1. My hypotenuse is 2, and across from the 60 is root 3. The 60 would be up here. Once again, because I am in quadrant 2, that will be negative. I am going left and up in quadrant 2, and left is negative. Now I want the tangent. Tangent is opposite over adjacent. That will be 1 over negative root 3, which again needs rationalizing. So I'll have root 3 over 3 negative. Negative root 3 over 3 is the tangent of 150 degrees. Now I'm going to do the sine of 270. The sine of 270, oh boy, 270 is special, isn't it? 270 is on an axis. And when you are on an axis, you cannot draw a triangle. 270 is down here. When I am on an axis, I need an x value, a y value, and an r value. And we're going to let our r value be 1, always. If r is 1, then this point would be the point 0, comma, negative 1. Straight down, 1 unit, 0, comma, negative 1. So x is 0 and y is negative 1. I want the sine. I need to remember that the sine is y over r. So y over r would be negative 1 over 1, which is negative 1. Secant, negative 5 pi over 4. This is a negative angle. I'll take care of that in a minute. First, let's change it to degrees. Pi is 180, divided by 4 is 45, times 5 is 225. I'm finding the secant of negative 225. Negative 225 is this way. Kids, remember, going negative, this would be negative 90, negative 180, negative 270 if I'm going clockwise around the circle. So negative 225 is partway between negative 180 and negative 270. I need this angle right here, and it would be 45 degrees, because from 180 to 225 is 45 degrees. So I have another 1, 1, root 2 triangle with a negative there. Because again, one more time, I'm in quadrant 2, left is negative. Now I want the secant. The secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse. So I need hypotenuse over adjacent. So that would be root 2 over negative 1, or negative root 2. So the secant of 5 pi over 4 negative is negative root 2. Now we got some calculator practice. With these problems, groupies, please, please, please make sure you are in the right mode. It is absolutely critical that if you are typing in the secant of 200, the tangent of 8, the cotangent of 5 pi over 7, the sine of 183/12, or the cosecant of 3 pi, you have got to be in the correct mode. So I'm going to go through, I don't want to keep changing, back and forth, so I'm going to go through and I'm going to draw a circle around or put a check mark, I'll just put a check mark next to all the degree problems, or I'll put a D. This is a degree problem. It says 200 degrees. So I'm going to have my calculator set in degrees when I do that one, and I'm going to have my calculator set in degrees when I do that one. The rest of these are radians. I think the pies are a dead giveaway to you that those are radians. You may be confused about this one, but there is no degree mark. When there is no degree mark, it is a radian measure. If you have a question about that, for example, if I write down 60, that's probably 60 degrees, but if I don't put a degree mark there, you need to ask me. Sometimes I get a little bit lazy and leave off my degree marks. But they're here, here, and here. So I'm going to make sure my calculator's set in degrees. And now I'm going to type, oh shoot, how do I type in a secant? I don't have a secant button. You're right, 1 divided by cosine 200. That's what I type in. 1 divided by cosine 200. And that gives me a value of negative 1.06. How did it tell me to round? Thousandth? 4. Negative 1.064. Now I'm going to do this one. I'm going to have to use my degree and minute mark, which we've already reviewed today. So I'll press sine 183, second angle, enter. That gets my degree mark. And then I'll type 12, second angle, click down 1, hit enter, and the answer should be negative 0.056 if I round it off to the nearest thousandth. Now I'm going to set my calculator back into radian mode because all of these are in radians. And I'll just press tan 8. Negative 6 points, actually, that's going to round off. That's kind of a tricky rounding. That's going to round off to 800 because it's 799.7, so that'll have to go up to 800. So negative 6.80 is the tangent of 8. Make sure you are set in radians and just press tan 8. Now this is a cotangent problem. We're going to do 1 divided by tangent, 5 pi over 7. So I want you to type in exactly what I wrote. 1 divided by tangent, 5 pi divided by 7. Your pi button is over right under your clear button. And the answer is negative 0.797. Cosecant will be 1 over sine, so it's going to be exactly the same scenario. So 1 divided by sine 3 pi. Uh-oh. This one is undefined. Your calculator will give you some kind of error message. This calculator says divide by 0. I don't know what yours says, but it came up an error message when you type this in. That means you are undefined. The sine of 3 pi is undefined. Okay. Now we've got a couple of equations to solve. This is probably the toughest stuff. Although, since we have worked on this for so long, all these trigonometric concepts, it's probably easier for you now than it was at the beginning. Keep in mind these directions. We are not using our calculator, but this does tell me I'm going all the way around the circle. So my window of opportunity for solutions is going to be the entire circle. Somewhere in that circle, I'm going to draw some triangles. And I'm going to draw them wherever the tangent is root 3. Now, I need you to understand something. The tangent is root 3. Where can the tangent be positive? Well, certainly it can be positive in quadrant 1. Because in quadrant 1, adjacent and opposite are both positive. Right and up, both positive. But the tangent could also be positive in quadrant 3. Because in quadrant 3, adjacent and opposite are both negative. So when you make the fraction opposite over adjacent, that's what tangent is, opposite over adjacent, the fraction would come out positive. Now let's think of this as a fraction. It's root 3 over 1. So this would be root 3 and this would be 1. You're supposed to recognize that circle, or that triangle, I mean. That is a 30, 60, 90 triangle. This angle across from the root 3 is 60. So is this angle. The two triangles will always match exactly. So your answers are this angle and this angle. Now, this one is 60 degrees. This one is a little bit tougher, but I think you can figure it out. That red angle would be 180 plus 60, or 240 degrees. The red angle is 240. It's 240 because from here to here is 180, and then you're going 60 more. To get to this angle, you're going 60 past 180. So the two answers to the problem would be 60 and 240. Same exact scenario, only this time we have to figure out where the sign will be negative. Now remember, sine is y over r, opposite over hypotenuse. So you have to think of a triangle where the opposite side, or the y side, the vertical side, is negative. That would happen here. It would also happen over here. These are the two quadrants that have negative y values. Remember, sine is y over r. These are the two quadrants where we have negative y's, negative opposite sides. Remember, here are your angles. So these are the opposite sides. Okay, now what do we know about the sine? It's negative 1/2. So opposite over hypotenuse is 1 over 2. This side would be negative root 3. You're supposed to recognize that triangle. That triangle is a 30, 60, 90 with this being the 30. This is also a 30. Remember, the triangles are the same. So what are the answers? If you said 30, you're not quite right, because 30 would be in quadrant 1. We need to get all the way over here. So starting here and going all the way around, how big would that angle be? 180 plus 30 is 210. And then we have to start here and come all the way around. Now that's a trickier one. If you went all the way around, you'd be at 360, wouldn't you? But you stopped a little bit short. So can you tell how big this blue angle is? If you said 330, you are correct. So your answers are 210 and 330. Now we're going to do a couple word problems. We're going to need our calculators to do this. The little stars mean calculator. Obviously, your test is going to be in 2 parts. We want to find the height of a flagpole. Here's my flagpole. I want to find its height. And its shadow, which is on the ground. Here's the sun up here shining down. And the shadow of the pole is 27 feet long. And the angle of elevation of the sun, I can't tell if that's 3.9, I think that's 39 degrees. 39 degrees. There's my angle of elevation. Looking up at the sun. And I need to figure out what x is. So I'm going to write an equation. And the equation I'm going to write has to use the sides opposite and adjacent. Because in this right triangle, with regard to this angle, this is the opposite and the adjacent. So the tangent of 39 equals opposite over adjacent. Tangent 39 is opposite over adjacent. Now, I'll multiply both sides by 27 so that I have x by itself. And then I'll go to my calculator, making sure I'm in degrees. This is a degree measure, be in degrees. 27 tan 39, you can just type that straight in, and you get 21.864 feet. So the length, or excuse me, the height of the pole is 21.864 feet. Now we got something different here. It says, consider the tangent of 1,000 and the sine of 12 pi over 13 and the secant of negative 11. And we just want to know, we don't want to know what the number is, we just want to know if it's positive or negative. So that's going to depend totally on which quadrant you are in. So I'm going to think about 1,000. That's a big angle. 1,000 degrees. That's more than once around, isn't it? In fact, it's more than twice around. If we took 1,000 and subtracted 360, we'd get 640. Let's subtract another 360. I get 280. So now I can understand that this angle spins around 2 times. There's a 360, that's a spin. There's a 360, that's a spin. And then there's 280 degrees left. Well, where am I going to put that extra 280 degrees? Wouldn't it be right here? Wouldn't this be the extra? Yes, it's just past 270. What can you tell me about x and y in this quadrant? This is quadrant 4. X is positive, y is negative. To get this point, we would come right and down. Positive, negative. I'm interested in the tangent. This is x and this is y. What do I know about tangent? It's y over x. Y over x would be negative over positive, which is negative. So the tangent of 1,000 is a negative number. This one right here, now this is a no calculator problem, so this is a little bit tricky. You have to stop and think a minute. Here's my circle. This is 0. This is pi. Remember, all the way around is 2 pi. Pi is the same as 180. This is 90 or half a pi. I do not want to change that into degrees because I don't have a calculator and I can't do 180 divided by 13. Now I could, but I don't think I need to. Because this says this is the same as 12/13 pi. Is that a whole pi? No, it's a little bit less than a whole pi. I don't need to know exactly where this angle is. I just need to know which quadrant it's in. It is in quadrant 2 because 12/13 is more than a half but less than a whole. 12/13 pi is more than a half, but less than a whole. So it's somewhere in quadrant 2, which is negative positive. In quadrant 2, x is negative, y is positive. I want the sign. Which letter is sine? It's y over r. The answer is positive. The sine of that angle is positive. Secant, negative 11. Here is negative 11. Negative 11 is in the fourth quadrant. That's positive, negative, right and down. Secant is reciprocal of cosine. Cosine is x over r, so secant would be r over x. What can you tell me about x in quadrant 4? It's positive, so the secant is positive. R is not part of the conversation, you guys, because R is always positive. Now we're going to do some sketches. And I am going to change problem B. Problem B is just going to be 2 sine x. Cross the rest of that off. We are not going to talk about that. And question C, I'll put that up in a minute. Maybe you're still writing that down. Okay, so y equal tan 2x. Here we go. Tangent. Remember, let me put the normal tangent up here for reference. This is a normal tangent curve. It has an asymptote at negative pi over 2 and positive pi over 2. You need to know that. This is a tangent curve. But it has a coefficient on x. The coefficient on x is 2. That number divides the period. The period of the regular tangent is pi. So this period will be pi over 2. That means the labels get divided by 2. Everything horizontally gets divided by 2. Now these are already fractions. Dividing by fractions, that's a pain. So instead of saying divided by 2, let's say times a half. Dividing by 2 is the same as multiplying by a half. So that would give me negative pi over 4 and positive pi over 4. This curve has no amplitude. Tangents never have amplitude. They have no height. And its period is pi over 2. You do not need to fill in any of the other information, just amplitude and period. Now we're going to graph this one. This is number 2. I rewrote the problem. We're going to graph this one, number 2. This is a sine curve. Remember, this is the shape of a sine curve. A normal sine curve looks like this. The labels of a normal sine curve are 1 and negative 1, up and down 1. And then pi over 2 pi, 3 pi over 2, and 2 pi. Those are the normal labels. That's the normal sine curve. What have I done to this one? Nothing except multiply its amplitude. So instead of going up to 1 and down to negative 1, it's going to go all the way up to 2 and down to negative 2. There we go. Good work. And our last problem. This is a cosine curve. Now let me draw my cosine here just to remind myself. It starts at the top of the hill and stops at the top of the hill. Has the same exact labels as the sine. It it just starts in a different place. Okay? Now, what's happened here? Lots has happened. First of all, we put a negative on this, which means that your cosine is going to start at the bottom of the hill and end at the bottom of the hill. That's what the negative does. Second, the amplitude is only a half. So my amplitude is positive 1/2. Over here, I forgot to write it down, my amplitude is 2, and my period is still 2 pi. I didn't put anything in there to change it for that problem. Now this one I did put something in. The period's supposed to be 2 pi, but it's been divided by 2. That means my new period is pi. Everything's going to get cut in half. So the regular labels are going to get halved. In other words, I'm going to multiply them by a half. I am multiplying by a half because this number tells me to divide by 2. And dividing by 2 means multiply by a half. So I'm going to have pi over 4, pi over 2, 3 pi over 4, and 1 pi when I take a half times all of the regular labels. And that's it. Good luck. You got another sheet to do that's like this one. I'm sorry about the correction. I don't know what I was thinking when I wrote those equations. So I'll hopefully the sub will tell you about that before you take it home and do it. Have a great day.